To start my stream. No one should be, maybe there's someone on the stream. I don't know. I mentioned it to my high school students. We'll talk about that in a second, so who knows? Maybe they're on it. Probably not. All right, so first off, who am I? Who is this person teaching your class? Well, my name is Wesley James. Doctor in front of my name, which all that does for me is lets me teach it, and it means I wrote a big paper. I did my master's. I did all my education here at UCF, for good or for bad, however you do that. I mean, if it's good enough for me, it's good enough for you, I suppose. I sat right there when I took Physics 1. I was a physics major for undergrad, physics major, PhD, and master's. My research was how to better teach college-level physics in a way that makes it more accessible for students with disabilities and ultimately all students. So my research, while technically I have a physics PhD, was physics education research. So some physics coursework, but most of my research was actually how to better teach physics. My main job currently, so there's the UCF part. The next thing I'll mention is my main job currently is I teach high school physics at Lake Mary High School, so I teach standard physics and honors physics. It's a good time. The class sizes are a lot smaller, so the reality is I can actually teach it better. Unfortunately, you all have the pleasure of being 100 students, and I'll do the best I can. But you know, the nature of this is I stand up here, I can't answer emails. I will not get to engage with most of you all, and that is so sad, unless you come to my office hours, in which case, I'd love to meet you. Do my best to remember your name. If I see you enough times, I'll remember your name. If I see you once, no promises. There's a lot of y'all. Heck, if you don't remember my name, that's fine. I won't be offended. Also, you can call me Dr. J, professor, teacher, Mr. Dr. James. That's what my students call me. Whatever, I don't know. This is my family. So that's me, obviously, the person that looks like me. It's my wife, Holly, and then that's our daughter, Kenzie. She's almost 2 years old. She's great. She's so much fun. And then the last thing I want to mention is going to be a little weird that's up there. This is the only time you're going to hear me talk about this, so I don't want y'all to be intimidated by this. Don't freak out. I'm a Christian. I only mention that, and this is the only time you're going to hear me talk about it. It's going to take me 20 seconds. I mention that because my job here is ultimately to take care of you all. The reason I'm in teaching is because I care about people, and that stems from this part of who I am. Now, with that in mind, all you need to know is that means that I value each and every one of you as a human being, regardless of any other part that you may identify, anything, any aspect of you. All that matters, you're human, and therefore every single one of you has equal value and worth, and so that's the important part here. The other part is it is possible to believe things that are faith-wise and to be a physicist. A lot of people view those as two separate things, so I just kind of mention that as it's okay to have religious beliefs and be a physicist. And again, that's it. I am here to teach, not preach. You will never hear me mention anything about Christianity unless you specifically come to me and ask questions. So, it's just an important part of who I am, so I like to share it. All right, so before we start getting into the syllabus, we'll just kind of quickly talk about what is physics. What is this course you signed up for? Yeah. Oh, is it doing weird things? Bummer, what's it saying on me? It says there's 4 viewers. It's not working on your thing? All right, well, I'll check it out after. I tried to do a test one of it. It's working for someone. Great. If it's working for someone, it's not my fault. Now, again, I'll look into it. Who knows? Maybe it is my fault, but it's at least not, hopefully it's not mine. So yeah, thank you for letting me know. At any point, definitely if you all have questions, raise your hand. I do want to answer questions. If someone has a question, probably will have a question. I will mention the live streams are literally just a screen capture of this, and then there is a little thing for my face, but as you can see, I walk around the room. In class is the priority, on class is just offer as an option, but that is not the priority. So, physics. We physicists just try to make a user manual technical guide for the universe. We do not get to decide how the universe works, we just get to explain it. It's kind of like a car. If you stumble upon a car out there, it is what it is. The car exists as it is. So to that end, we're going to talk about the rules. It does not mean that they're absolutely correct, but it is our best current understanding, and a lot of it is probably pretty darn good considering we're able to build useful things with it, and it's been consistent up to this point. But there has been plenty of cases where we thought we understood something, and then something new came along, and it was like, ooh, our understanding wasn't quite perfect. An easy example of that Classical mechanics means that I completely know where this desk is, I completely know how fast it's going, we can understand things 100%. Get to quantum mechanics, turns out when things are real small, you can either know where it's at or how fast it's going, you can't know either 100%. So things get weird at small scale. And that just shows that our understanding is always evolving. You know, the easy one is they thought the Earth was the center of the universe. They were wrong, and I can guarantee you there'll be things that we're wrong about as well. Humans make mistakes. You're going to see me make a lot of mistakes. Not because I want to, but because I'm a human being, and so the same will also apply to all y'all. All right, so we're going to be talking about mostly just moving objects. I guess they could not be moving as well, but at some point they'll generally be moving. That is the nature of this class. Position, velocity, acceleration, time, force, energy, all those kind of things. Basically things that you can see with your eyeballs, describing why they do what they will end up doing. If you take physics 2, which I think pretty much all of you will have to do, assuming everything goes smooth in this class, you'll talk about electricity and magnetism. I teach the non-calculus-based version of that class on Tuesday, Thursday. So if you want to watch those in the live stream, they'll be there. But that's a lot of physics, and it doesn't calculus-based, but it doesn't change too much. All right, so we're now going to kind of go through the syllabus. This is basically what I'm going to spend most of the class on. What is the structure of the course? How is it? Why is it designed the way it is? How is it designed? All that kind of jazz. Not very exciting, but probably one of the most important classes for you to determine how to be successful in this course. So I'm going to jump to, we'll do the syllabus first. So we'll do web courses so you can see where the syllabus is at. So if you go to web courses, I made the home page have the syllabus in giant font there. You can download the PDF if you ever want to view it. It is there. And then it has, you know, a bunch of things here of due dates and all that jazz. But the syllabus is here. And then I also want to point out while we're here, I've told you all every single thing I have in class will be available online. So to that end, week 1, bam, there's a PowerPoint I'm going through today. It is in both PowerPoint and PDF version. As I write on the PowerPoint, I will upload. So after today, if I actually write on the PowerPoint, I will upload them with writing. It will be in PDF because the writing does crazy things and PowerPoint doesn't look right. So I will upload those as a PowerPoint PDF as well. So this folder will be full of 8 different files. But after the end of this week, you just want the one that's the latest date. But I'll update it every day just for your own, so that way you're not waiting on me. So bam, every file will be in here. There will be a couple other things that'll be posted in here. This is where I put everything nice and organized week by week. We also have these problem sets, what I'm going to talk about in a little bit. All right, so great. Here's the syllabus. Here's me. So a little background on me, woohoo, and all the things I already said. There's my email, wesley.james@ucf.edu. You can either email me with that, or you can just send the thing to web courses. Both go to that email. I will make the commitment to respond to you all within 24 hours. That is my commitment. That could be within an hour when you send it. That could be 23 hours later. But it will be within 24 hours. With the exception of weekends, I have my nice work-life boundaries. And on weekends, no, I'm not checking my email. But throughout the week, I totally am. And I can guarantee on Monday, I will go through all the ones that came over the weekend and reply to those. So there's that. I will tell you, as I mentioned, I'm a high school teacher, so today I was teaching high school. So that does mean throughout the day, you know, when I will respond to those is going to vary. That's why it's not going to be immediate. If I was just doing this gig, just teaching college, sure, it'd be probably even shorter than that. But throughout the day, I'm usually busy working with high schoolers. The course location is here. Great job, you made it. Office hours are in PSB 146. Let's just pull up a map of UCF in case you don't know where PSB is. That is completely normal if you don't know where PSB is. I did not know until I was a physics major. All right, let's see how big I can make this. Okay, so this is probably very difficult to tell where we're at, but I'll do my best to make it clear. There's the reflection pond. Okay, so we're going to kind of use the reflection pond in the center of campus as our thing. So as hopefully you know at this point, if not, that's okay. UCF is all about circles. Circles galore. Circle pathways up in Wazoo. So this is us in MSB. This is the outer circle. So if you kind of go farther away from the student union, you hit this outer circle. If you take that outer circle and you just keep walking counterclockwise, You will quickly end at the PSP. It's a big rectangular building about 4 stories. It is exactly 4 stories tall. That is where the physics department is, and that is where my office hours are. My office hours are on this front, depending on your perspective, as you're walking towards it, it's on the corner of the building closest to you. It's PSP 146. I will be in there for you all Monday and Wednesday before class, 3:30 to 4:15. Sometimes I can get from my high school to here quicker, and I'll get there at 3:15, but no promises. But as soon as I get off high school, I head straight here, I pop into the room. Either I get there at 3:15, 3:30, or somewhere in between. And then I'll be there until 4:15, and then I pop over here and ta-da, here I am. Now, I told you I have office hours Monday, Wednesday. I technically also have office hours Tuesday, Thursday, because I teach second class on those days. So, to that end, if needs be, you can also pop by Tuesday, Thursday from 3:30 to 4:15, but I will tell you I'm going to prioritize the Physics 2 class during those times, and I will prioritize you all on Monday, Wednesday. But if you're at both and I can manage both, I'll do my best I can. But come by and visit me. I'll be there. It's a great opportunity to ask me questions. You definitely want to be working with someone in this class. I can be someone else in this class can be someone, tutors can be someone. Unless you've taken physics before, I'm going to go ahead and tell you all, this is a jam-packed course. Specifically the first 6 weeks, we got a lot to get through, just based on how the course map is. I don't get to decide the course map, I just teach it. So, there's a bunch we got to cover, and to that end, in general, every single class that you all have, where you are doing calculations, I mean, probably most classes in general, but as a physics major, I cannot stress enough the importance of working with other people. So honestly, at the end of class today, look around you, try to talk to at least one person around you. People like to sit in the same location, so if you don't do it today, do it the next class. Get to know someone around you, if you don't already know them. And just simple stuff, working together on problems, texting each other if you have questions on things. It is a great strategy because you are going to make mistakes in this class. I already told you I'm going to make mistakes. I'm a human. You're also human. You're going to make mistakes. One of the best ways to assist that process is to have someone else. If you're working together on a problem with someone and you both get different answers, one of you is wrong or both of you is wrong. You're not both going to be right. The beautiful thing with physics is there's only one right answer to every problem. Whether you like that or not, that's just how it works out. That's the whole point of physics. We're trying to explain how the world works. The world is cause and effect. You drop something, it falls, assuming the same conditions every single time. All right. Great. There's office hours. The book we're using, you don't have to pay for it. It's OpenStax. In fact, there's only one single thing you need to pay for this class, and hopefully it only costs you like 15 to 30 bucks, and that's it. That's a priority of mine. We'll get to what that is in a second. Bam! Here's all the things we're going to cover with each week that it's going to be covered on. So today, or this week, we're doing units, measurements, and vectors. In fact, let me just scroll to the end. I think this is probably one of the most useful things in the entire syllabus. I have outlined what we are covering every single week. I have the exam dates on here. Those are set. Because I showed those to you all, I will not change them. That means you can plan around those. I do need to update the final exam. When I was making this, they didn't have it posted. At this point, I should hopefully be able to look up when the final exams are. You should also be able to look that up. But I'll put that on here sometime this week. Exam 1, notice it's on 2 days. We'll talk about that in a second. Same with exam 2. And then there's the final. So bam, I just wanted to show you all when all the weeks are. Here's, all the deadlines and stuff like that. Classes begin. Drop swap deadline is this week. Same old, same old. The withdrawal deadline is March 29th. Every kind of piece of useful information about dates is here at the end. All right, so let's get into what the heck the structure of this course is. Obviously, I'm teaching you physics. That's why you're here. How am I doing this? How am I assessing your understanding? All that jazz. Here's the breakdown. There's clicker questions. Those are done in class. Some of you may like that. Some of you may not. I'll talk about it. There's quizzes. I call them quizzes, but they're not as bad as they sound either. 2 midterms, which you just saw, the finals. So actually, let me break down the percentages. 13% for clicker questions, 25% for the quizzes. Midterm exams are 30%, final exam is 20%, and the discussion section is 12%. The way this breakdown should work, as I unpack this, what I want y'all to take away from this, 50% of the grade is tests, 50% of the grade is more effort-based. I know it says quizzes up there, but I'm going to show you all that these quizzes are kind of my analog for homework. So 50% of the grade is points that you can get by just putting in effort and time, and then 50% of it is, do you understand it? So let's kind of break down each part. Lecture, great. I'm here, I talk, PowerPoints, all that jazz, great time. All right, quizzes. Something that is very, very important to me is that the things that I teach you look like the things I test you on. When I was doing my research and talking to students, one of the most common complaints I heard was that the tests don't look like the homeworks, or I don't know how to study for the tests. Very common concerns. So to that end, my course design is based around that. To that end, there's going to be, let me actually just show you all these problem sets. They're not mentioned here. So I'm going to go into, let's go into web course and I'll just show you where you can find them. Every single test, so test 1 has this problem set. Test 2 has a problem set. And then the final will be cumulative, so problem set 3, that's the last stuff we cover between test 2 and the final. These problem sets each consist of so let me just pull one up so I can talk through it, and then I'll tell you how it's connected to the work in this class. These are not graded. These are not a requirement for you to do. But here's how these works. Every single week, so we can see here week 1 is unit measurements and vectors. Week 2 is kinematics, 1D kinematics. 2D kinematics, week 3. Week 4, circular motion Newton laws. Week 5 is application Newton laws. Bam. Every one of these has about between 10 and 13 questions or so. Maybe one is 14, I don't know. Something around that, but no more than 15 for sure. They have the solutions, the answers to every single problem in this. And the purpose of this is what I want you to practice to make sure you understand these problems. This is kind of like homework, but it's not graded. The answers are there. And then what do I use this for? The quizzes, when I make the tests, I look at these, I look at the clicker questions, and then I make versions of the problems that are similar to them, but not the same. Kind of reworded, but asking similar things. So, if I asked you to convert units, there may be a problem where you convert units kind of thing. So this is basically, I look at this to make my assessment questions. I chose all of these questions from OpenStax. I then use these to make the quiz questions. I then use all of that to make the test questions. So, the rule of thumb is if you can do every problem from that week, you should ace the quiz. Because the quiz will be problems like these. Now, so this is kind of, hey, how do you prepare for the quiz? You do these problems. I will do some of these problems in class as well. Some of the trickier ones and ones I think will really stand out. Yes?
So I do a lot of my work on the tablet.
Yep.
And some of the docx files can kind of be like wonky.
Sure, I'll upload them as PDF.
Okay,
yep. In general, most things are PDF. The exception is these have been docx, but I'll go ahead and upload this PDF for sure. Because yeah, they definitely do get a little wonky depending on that. Yep, so that's easy peasy. I'll do that by the end of today. Thank you for asking. I appreciate that. Now, the quizzes, let's kind of go back to those and how those evolve from these. The quizzes are only 5 questions. They're 5 questions, and you get 2 attempts on it. Now, here's the cool thing about the quizzes. Each question on the quiz has multiple versions, but they are basically the same problem. So what is a possibility is you can take the quiz, you want to prepare for it beforehand, give yourself the best chance of success, do it, see the answers you got, see basically what you got right or wrong, and then do the quiz again. And it'll be the same, very, very similar. I literally take the questions and I change one thing in them. One single thing. Maybe a number, maybe a word, just, be careful on that. So the quiz is, you get 2 attempts on basically a very, very similar version of the first one, just different numbers. So it's not like it's a one and done situation. So it's 5 questions. You may be like, oh man, that's rough. If I miss one question, I get 80%. To avoid that, I grade them out of 4.5 points. So in web courses, I can't change that in the native quiz. So what I will do later on in the quarter is I will take these quiz grades and I'll move them over to being worth out of 4.5 points. What that means is if you get all 5 questions right, you got over 100% on that quiz. So say the next quiz you get only 4 right, they even out, you got 100%. So I try to do the most I can with this to make these, this is not supposed to be a high-stress situation. These quizzes are done on your computers, they're 40 minutes, some of them I gave you even more than 40 minutes, so I'll make sure you have enough time to actually think through them. But not so much time that you're just sitting around and you can Google all the things. Heck, you can use anything you want. You can Google stuff. I typed up these questions as they currently should not exist online with solutions. I have no idea how they would. They will by the end of this semester, but for now they don't. You can search these up. I don't care. I want you, the purpose of these quizzes is I want you to learn how to do these problems. Quizzes are both one way of me making kind of a way of you monitoring whether you're learning it, and also helping you to learn it. So again, it's like a homework. But the whole point is the problem sets. You can do as much or as little of those as you want. Instead of giving you 20 problems to do each week that you have to do, I give you 10 to 13 problems. Do as much or as little as you need to make certain you're successful. And then I also chose those questions, as opposed to me giving you some random questions that someone else made that may or may not look like the test questions. So, there you go. Any questions on this? All right, you all have a better sense of these as after you've done one or two of them. Oh, I also dropped the lowest quiz grade. Forgot to mention that. So out of the 12 quizzes or so, I dropped the lowest one. All right? But yeah, the key to this course is everything revolves around those problem sets. If you come to me at some point in the course and say, what do I need to do to be successful? Like, I'm not doing well, what's going on? First question I'm going to ask you, how are the problem sets going? If you said I haven't done the problem sets, I'm going to say do the problem sets. It sounds very boring, sounds very lame, but that is why they exist. I've spent a lot of time kind of curating them to make certain that the problem sets cover every type of problem I want to ask you on a quiz or a test. They should be represented. They are representative sample of the information that you need to know. Now, the quizzes will also have kind of conceptual-ish questions. Those will come from the clicker questions, which is a nice segue. So the clicker questions are worth 12% of the grade. These are based, or 13%. 13% of the grade. There's a lot of important pieces of information here. So clickers are the only thing you have to pay for in this class. You can either buy the digital version, which goes on your phone, and that means if you're watching live streams, you can answer from your phone online. I try to set the delay as low as I can on YouTube streams, but there will be slight delays. So as I'm doing the question up here, if I give you a minute and a half, you may only get like a minute 20 or something if you're at home. So just heads up on that. Or you can get a clicker. Any clicker works. Any clicker, use clicker, doesn't matter. But you will need to register it. I sent out some information about how to do so in the announcement. I put two announcements. One is, hey, welcome to the class. Glad to have you all. Second announcement is how do you access the live stream and how do you register your clicker. Now, the cool thing about these clickers, I give 75% of the points for just answering it. 25% is for getting it right. These are low stakes. These are basically, I just want you to try. And to that end, say I ask 100 clicker questions across the entire semester. I have no idea how many clicker questions I'm going to ask. Each class is going to vary. I can't promise how many. Sometimes I have the inspiration to come up with a new one, and I'll make one during class, whatever. But let's just say I ask 100. I will only score them at the end of the semester at 75 points. Meaning, every single one you got right was just bonus points. So if you miss a question, but you answer every question the whole semester, you get 100% for clicker questions. Again, 3 points. This is effort-based. This is part of that effort-based in the class. Participation, all that jazz. The last part, some people don't want to show up to class, and honestly, I don't want to force you to show up to class. Some of you have taken physics before. Some of you are going to pick this stuff up super quick. I have no idea what percentage of you that is. You have to decide that for yourself. To that end, at the end of the semester, this will not happen before because it's just, don't even know how I would do it. At the end of the semester, I will calculate every single person's grade with the clicker scores and without the clicker scores. If your grade is higher without them, I'll take that. Basically, that means that that's not a part of your grade. It means everything else is worth a little bit more. If the clicker scores make your grade higher, that's the one I'll use. So if you don't show up to a single class, meaning you miss out on this 13%, that just means everything else will scale up accordingly to make up that difference. Okay? So if you want to show up, you want to do the clickers, please do. My hope is that my time spent up here is useful for you all, but you do you. I'll be here either way. It does not hurt my feelings if you're here. It does not hurt my feelings if you're not. I don't know why it hurt if you're here. It does not hurt my feelings if y'all don't show up. If you do have an excused absence, still email me and I will make certain you don't get penalized for those points though. So if you're like sick or what, if something, you have an excused absence, we'll talk about the excused stuff. It's the same you hear in every class. Email me and I will adjust it for whatever that last class was. All right, recitations. This is the one thing that I have very little control over. The recitation sections are not decided by me. They are across class, every 2048 classes to do these. They have to be fairly consistent. The way these work is you all have signed up for a recitation section. 25% of the grade is attending that recitation section. The other 75% is every time you all have these recitations, there's basically a quiz, I'll call it. It's called a recitation activity with some problems. You will work on those problems during the recitation, meaning if you are there, not only do you get the 25%, but you should also get 100% of the points for the recitation activities. So, again, effort-based. If you don't show up, you'll definitely lose the 25% for attendance. Again, that's kind of, this part of the class is not as much of my control as the rest. And then you'll take this, and what you get is what you get, kind of thing. So, I recommend showing up to them. The problems are useful. You can work together, get to know your students, your classmates, all that jazz. You have a better chance of doing well in these. I am playing around with giving a couple attempts on them, but as it stands, there's one attempt. Mainly because there's not multiple versions of the problem. Straight up tell you that. So because there's not multiple versions, obviously if you take it once and it kind of shows you, then that's a problem. All right? Cool. To that end, while I mentioned this, I was debating whether or not to do this, but I'll do it. On these quizzes, after you take your attempt, it will tell you which questions are right, and it will tell you which ones are wrong. Okay? So you will get that feedback as well, so that way you focus on the problems that you don't. That way you know which ones you actually didn't have to do. So I'm not 100% if that's already built here, but if not, I'll go ahead and do that. Oh yeah, also the quizzes. Let me give you all some time frames of the quizzes. The quizzes are going to open on the Friday, so quiz for the week, stuff we're covering this week, that is not going to even open until the end of class on Friday. Why? Because I'm not going to open a quiz for something we haven't covered yet. At the end of this Friday, you will open and you will have all the way until Saturday at midnight to finish it. Again, if you wait till Saturday to work on it, you shoot me an email, I will not respond. So don't recommend waiting until Saturday to ask me questions. But it will be open from the end of this Friday to the end of this Saturday, with the expectation you're working on the problem set either kind of throughout this week into next week, so it gives you time to do the problems in preparation for it. Be prepared going into your first quiz attempt, but also give yourself time between quiz attempt 1 and quiz attempt 2. If you take it back to back, give yourself time to process, learn from your mistakes, all that jazz. If you take quiz attempt 1, you're like, oh crap, I know exactly what to do, and you fix it. Give yourself some time. Give yourself some time to make certain you're good to go. All right, so there you go. Quiz are going to be like that. The only thing that I guess to note there is that that does mean that this quiz is going to be during the exam week. So that one you are going to want to kind of start a little bit beforehand. You have the same amount of time, but this quiz will be actually due after the test that's also going to include it. It's just the nature of how timing works. I can't really fudge it any other way. Opening it later doesn't help you. Opening it sooner doesn't. I can open it sooner. I'm not too bad about that. All right, let's see if we got everything in the syllabus. So recitations, bam, those are there. All the grades will be posted. Normal grading scheme. Missing, the classic. Missing work. There's not really too much to say about that. Cell phones, I don't really, as long as you're quiet, I don't really care. You're not high schoolers. Don't cheat. Course accessibility. I will stop here. Please, 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 if you do have if you have any of the things through SAS, through Student Accessibility Services, extra test time, anything like that, or if you're even on the fence about getting those, please get them. Please make use of them. They exist. They are for your use. They are great. They're there for a reason. I want you all to make use of any and all supports you can. For some students, that includes these accessibility things. Please make use of them. You'll receive only support from me in terms of using them. If you have extra test time, that will also qualify on the quizzes. So if you have extra test time accommodation, that will also apply to every quiz in this class as well, because it is a time-based activity, and so I'll make certain you have that time. All right, so there's that. And I reserve the right to make any changes. But again, I can promise you all, unless something crazy happens, these test dates are set in stone. So I will quickly talk about the tests. Why are tests on 2 different days? I want to give you all the best chance to show your understanding. And so the dream would be I give you infinite time. I don't really care about time. Not many things in life are timed except for tests. Sure, you have deadlines for things, but those are usually like weeks or days, not an hour. To that end, the only way I can give you more than 50 minutes is to give you 2 classes. So these tests on Wednesday will be the multiple choice part of the test. That is worth, my current plan is between 60 and 70%. That's kind of fluid based on how I see performance goes. I like to leave a little bit of how that's going to go. I will tell you all, this is my first time teaching 2048, which may scare you, but trust me, I've taught this stuff. I teach high school kids. I have taught this content at DIT. But if you have concerns about the quality, at any point come talk to me. But to that end, that means I haven't given a 2048 test before, and if you all have experienced your classes, the first test is always the biggest uncertainty. How's it going to go? How's time going to go? All that jazz. Know this. I will not let everyone fail. If everyone fails, that doesn't mean that you failed, that means I failed. So to that end, if the first test goes disastrously, for everyone, for a lot of people, the majority, that means I need to evaluate how I design the test, and I will take certain measures, curve it, blah, 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 do those kind of things. So keep that in mind. That's why some of this stuff is a little loose, because I want to keep things flexible. So we're probably going to say 70% of the grade will be 60 or 70. Again, I'm not 100%. Will be the multiple choice. I'm thinking 20 questions. I need to make the test. I need to time myself for the test. I need to make sure that you all have enough time in that 50 minutes to both do the work, but do it carefully. All right? On the Friday is going to be free response. My current plan for that, again, I may shift things around as I make the test, is to give you 3 questions. These are going to have many steps to them, and I will ask you to do 2 of them. You can pick any 2 out of the 3. That is the current plan. Again, that may go up. It definitely won't go down. I need to make certain it has enough breadth. But that's the current plan. If that is too short, I have to do the balance between having enough questions so that if you miss something, it doesn't kill your grade, but not so many questions that you don't have the time to think through them and process them. So that's the balance. And again, I'll make these sometime later in the semester as I see how you are doing on the quizzes and all that jazz. Yeah?
Can you attempt all 3 and you'll take?
Yes. So as we get closer, I'll talk about that. If you do all 3, the grading scheme, so I have a rubric. I'll post that rubric in terms of partial credit. So the free response ones on Friday will have partial credit, meaning someone has to actually go through and grade all of them. That will be a grader, not me. And to that end, I am not going to have them go through and grade all 3 of them. So the way it'll work is you'll mark which 2 you want to be graded for partial credit. But I will tell the grader, check the 3rd question. If their answer is correct on it, the numerical answer, then they'll just give you all the points for that. That way it makes their grading super quick to kind of give you that option, but at the same time, I gotta respect the grader. There is only 100, I say only 100. The last class that taught had 200, so half the grading. There's only 100 of y'all. But yeah, basically we'll talk about as we solve problems, how partial credit's gonna be assigned, what things they'll be looking for. They'll be related to the problem solving strategies that I'm gonna teach you all. If you just put an answer on the free response and it's wrong, obviously, nope. Like, you can't get partial credit if there's nothing to get partial credit for. So as we get closer, I will talk about that more in detail. But yes, if you do all 3 and say the 2 you pick, one of them, the final answer isn't right, but the 3rd one, you have the right answer, that's easy for the grader to just be like, yep, all right, all the points on the 3rd one, I'll skip that one, then you can get as many points. It's a good question. All right. And I think that covers it. Again, it's a lot of information. It's going to make more sense as you engage with this course. But the things to remember, problem sets are for you all. Do all of them? Do none of them. But if you do none of them, I'm not quite certain how you would know that you understand physics. I guess you just have a feeling in your soul. They're for you all. They have the answers there. Google them. I got these problems from OpenStax. Now, pro tip to solving physics problems, try them before you look up the solution. Try them before you look up how to solve them. Because it's kind of like a magic trick. Once you see someone do the magic trick, you know how it's done. You don't really have to think about it. You have to think a lot more when you don't know how it's done. But the solutions are there because I want you to know if you have the right answer. There's no point in doing a problem if you're doing it wrong. Again, beautiful thing with physics. There's only one right answer to every single problem. So the answers are here now. I will straight up tell you all, these answers came from OpenStax. I assume they're all correct. But if they're not, shoot me an email. If you all catch any typos, the links are to reward you. Alright? So for those go-getters that like to get ahead of the game, if at any point you're like, ooh, I'm not certain of the solution, email me. Can't hurt to ask, I'll double check. If you found a typo in my stuff, I will quickly update it, I'll notify everyone else, and I'll make sure to reward you for your effort by some points somewhere, somehow. Maybe an extra quiz point or something. So there is a benefit to you identifying these. Hopefully nothing else has typos, but again, this is the first. You are my guinea pigs. That comes with it. That comes with downsides. That means there could be typos. That comes with upsides, meaning you get the most grace, because I know if there's typos, I'm not going to penalize you all for that. So there's upsides and downsides to these kind of things. And I'll tell you all, last year I taught 2054. That's Physics 2 for non-engineers. And at the end of it, it all went smoothly. The first test I gave, 10 to 20% finished before the class ended. If you're taking a test, that's not a good sign. During the first test, an indication of whether I've designed a good test, whether 50% or more of you all are done before the class ends. And what did I do? Actually, I implemented something that I mentioned this as well. I implemented one, I curved it. I actually removed the written part of it because they didn't have the time to finish that, so I focused on the pre-response. 2, and this is something I'm scratching for y'all. I made so the final test grade, this is also true of this class, the final test grade will replace your lowest exam grade. Okay? If it improves your grade. If your final grade is a 60 and you scored better on the other 2 tests, I'm not going to hurt you. Okay? But if your final grade is higher than either of your first 2 test grades, it will replace that because the final is cumulative. So that's kind of your second chance to show that you understand stuff, learn from it, all that jazz. To keep it equitable, if you are sick or unable to make the test for an excused reason, I will let you retake the quiz or the test during my office hours. The week following office hours, you can come in my office hours, any one of them. Monday, Tuesday, Wednesday, Thursday. Heck, I'll even be there Friday. You can come and retake it. So that way it makes sure that everyone has a chance to take the exam and benefit from that. But that is kind of the window I have for you to take it, is the week following it. If that doesn't work, we'll figure something out. If you just miss an exam, you just miss exam 1, not for an excused reason, shoot me an email for 1, but again, the final will replace that one guaranteed, because it's very likely you'll do worse than a 0. So, you got that kind of in your back pocket to make things easier. Do you all have any questions about the course structure? Yes?
About the quizzes,
Mhm.
when you take like the second attempt,
Mm-hmm.
is it going to score the highest one? Or
Yes, that's a great question. I will take the highest of the 2 grades. If you do worse than the second one, it'll keep the first one automatically. Yep. It's a good question. And yes?
Are the quizzes open for like the whole next week?
Yes. Every single quiz will open the Friday that we finish the content, and then will be open a week and a day. So the Saturday following that. Yep. Yes.
I know several classes with OpenStax, like we don't use the whole textbook, you're just pulling from parts of it. Is
Yes.
that true for this course?
Yeah, that is true because they cover, we already are covering a lot, and they cover even more. So in general, the OpenStax textbook, you can generally kind of tell what sections are going to go with what we cover. So feel free to use it as an additional study resource. But yeah, we're not going to use everything in every chapter that they have. Anything else? All right. So we'll go ahead and start talking about today. I will say that, so we're going to get through some stuff today. We got 7 minutes. These classes are short, and we have a lot to cover, so I can almost guarantee every single class we're going to go, you're paying me, so I'm going to give you my time. Every single class is going to go to 5:20. I can almost guarantee you all that. We do not have class next Monday, which is a little unfortunate, because I got to cover 1D kinematics. I will tell you it's likely 1D kinematics may kind of wrap around, 2D kinematics. So we may wrap around like a day at which point, because I know that I may extend the quizzes, we'll see. Again, there's some fluidity here. Any change that I make to the course will only benefit you all. I will never do something like move a date sooner. I will never do something like make something worth something difficult, something that people didn't do well and worth more points. So just keep that in mind whenever you hear me saying changes. But I can tell you the test dates are set. I will not change those. Whatever may come. Okay, I guess if we're out of school for 2 weeks due to another COVID, we'll see. But pending no natural disasters or whatever disaster you want to say, that is basically set. All right, so quick. This is what you need for this class. This is just the important skills you need. You need to be good at algebra. I will be showing some algebra steps, but you all have taken calculus, so I'm assuming you're decent at this. If this was an algebra-based course, meaning a non-engineering-based course, I would maybe show a bit more. But I have higher expectations for you all because you're engineers. To that end, that's going to relate to how I work out the problems. If there's a math step, you're like, wait, how do you do that? Just either come back in class, or you can actually, that's also perfectly fine. But I'm not going to show every single step for algebra. I may skip a step here and there, maybe combine 2 algebra steps in one. You all have done calculus. I have more confidence in you all. Whereas in my algebra-based course, math skills may not be as strong, so I may be more, how to put it, detailed, let's say. All right, you need trigonometry. We're going to do stuff like vectors, which you all cover, like this is a question. Do you all cover vectors in calculus? No. And break out. All right, so you may or may not have seen it. That's okay. I'm going to teach you about vectors this week. Some of you may have seen it, some of you may not have. But basically, vectors are going to come down to trigonometry. We're going to draw an arrow. We're going to make it into a triangle, hence the trig part, tri, for 3 sides. The up part will be the y. The bottom part will be the x. You'll see that in a bit. But we're going to be working with triangles a lot. That is one of the reasons why this first 6 or so weeks, 5, 6 weeks, is going to be the trickiest. This first test is going to have the hardest stuff on it because there's a lot I have to teach you. I have to teach you how to think like a physicist. Meaning, I have to teach you how to set up problems. I have to teach you about a lot of variables. I have to work with vectors and break things into components. The first 5 weeks is the hardest stuff in the class. And then it gets easier. Alright? So just keep that in mind as you are going through this stuff. You're like, oh my gosh, there's so many math steps. They will kind of reduce as time goes on. Plus, you will get more proficient with the language of physics. Physics is all about using math as a language to understand the logic of the world. That's how I like to express it. Math is a language. And in this class, you're actually going to use that language to understand the world, to speak to how the world works. I have provided, I don't know about this. I did that for 2054. I have not done that for this class. Khan Academy does have great stuff if you feel like your skills are a little rough in any of those areas. And now behold the problem-solving strategy process that I'm going to use, not quite in every single problem, but this is the strat to solving a lot of problems. This is the process I'm going to be using. I will write step 1, I will write 1, 2, 3, 4, because one of the biggest questions you'll have is, I don't know how to set the problem. This breaks it into pieces for you. First step, you draw a picture if possible. We are describing the world, and in this class, we're describing parts of the world that you can actually see. When you get to physics 2, like it's a little trickier, but you can generally still draw pictures even for those. Even if you can't see it, you can still generally draw a picture for it. So, if possible, we will draw a picture to help us visualize what's going on. Because we're trying to make meaning of something in the world. That's why I love physics. It's not just doing math for the sake of math, it's using math to explain something real, something physical, something that exists in the world. Alright? Next, we're going to identify what's given in the problem. What number goes with what variable? 3 meters, that's going to be position. 5 meters per second, that's going to be velocity. We're going to get a lot of measurement, learn a lot of variables in this class because there's a lot of different things you can measure. We'll start with just a few and it'll build as there's more things that we develop. Alright, next you identify what you're solving for. And if you're lucky, there will be an equation that has what's given and what's missing. The reality is, sometimes you'll need to do a few steps. Sometimes you will need to figure out the process to solve it, giving that information. Sometimes you will say to solve step 2, I need to solve for something else. We call it a 2-step problem. You have to solve for something else first, and then you can solve for that. How do you get good at figuring that out? You do enough problems. It's one of those things that once you've seen a certain type of problem, you can ideally then see one that's like it and be like, oh, I've done one like this, I approach it this way. That's what the problem set is for, is to show you, hopefully, the breadth of the types of problems I expect. The paint job may look different on future ones, but it's the same car underneath. Alright, so that's the goal with the problem sets. And then you plug everything into an equation and you chug. As we solve through these, you'll see what I mean. Alright, this one would ideally be, what is 3? So this gets into the actual content. That was everything that you need to know. That was kind of the cross reviews. What is 3? It is nothing. 3, what is 3? This is a question I ask when I am teaching my high school students. This is the first question I give them as well when we're talking about units. 3 is an idea. 3 means nothing. What is 3? So the analogy, the thing I say is, if I told you I would pay you 3 to mow my lawn, would you accept? 3 what? 3 cats, $3, 3 cents, 3 bars of gold. 3 means nothing until you put something after it. 3 an idea. Numbers are all just ideas. Physics, we make them mean something by putting a unit after it. And it is very important that you put units after things. Otherwise, what does it mean? Even distance. If you say, oh, this is 5 away. 5 meters, 5 feet, 5 miles, 5 kilometers, 5 centimeters. There's almost, not quite infinite. There's a lot of things it could be. You need to put your units. And we're going to do some practice with this. Anytime we do an equation, all our equations are tuned to work with base units. The key to base units is they're generally, this doesn't work for everything, but it's a good thing to keep in mind, a single letter. We're going to see some cases where it's not, but for the most part, it's a single letter. When we get to distance, M for meters. When we get to time, S for seconds. If you see a letter in front of it, G, K, C, M, that means it's a prefix. And some of this will be familiar to you all, some of it won't be. For some of you, it won't be. We're going to do some practice with it. The only exception to this is kilograms. Kilograms is the base unit for mass. We'll see that later. For whatever reason, they didn't make grams the base unit. I didn't make that decision, but it's how it is. So you'll see that most of the base units we talk about are a single letter. You put a prefix in front of it, bam, you're good to go. All right, and we're out of time. So we're going to finish up units next time. Hopefully get into vectors, because units aren't really that bad. If you all get your clicker working, I'm going to start asking clicker questions this Wednesday and Friday. They will not be a part of your grade, but I will post the grades so you know if yours is working. So please get your clicker as soon as possible. Next week is when they start making points, but I will start using them so you can make sure yours works. If you have any questions, come on down. What's up?